Morning all. We might have heard a lot for the last, I would say, a decade or so. Once the automation, the wave of automation, once it comes in, it's going to be another industrial revolution. People would lose their jobs, etc. But there is one thing that people will not lose. We need more people with creative jobs, or wherever there is a customer experience that is involved. Those are the jobs that's going to be secured. So I'm sorry I'm here. I'm going to be disappointing you. We might have to take that statement with a pinch or maybe a bag of salt, because over the last couple of years, what we have been trying to do is, if we can automate the entire process of innovation, can we automate what a scientist does or what a Six Sigma black belt does in his organization? So this is the process that we are into, and we have kind of identified, I would say, a partial breakthrough as well in this. And so what I would be taking through in today's session is how the journey that we went through in trying to automate the intelligence of the scientists and the innovators. Second thing is how do we use or how to optimize the entire process of innovation in itself. How do we identify an opportunity for innovation? It could be using and then use a tool, could be an AI or RPA, cognitive, etc., and then sell it. And surprisingly, this entire process can be done in 45 minutes. So what I mean to say is, in 30 to 45 minutes, there is a potential white paper or a patent that can come from this room. So this is what I would be talking about. So here is the problem. In 2013, we started questioning, how do we start automating the process of innovation? For that, we had to understand innovation. Then that is where we started knowing more and more about AI. So as we all know, for AI, there is one key thing that is required, a training data set, right? And so if we want to automate the process of innovation, we need thousands and thousands of innovation, and it has to be a structured data, and there has to be a very clear input on what a particular user or the customer is planning to innovate. What is his goal? The AI should understand the goal. And finally, there has to be an output. Or that could be the problem that he is trying to solve. Now, we don't have that information. One source is getting into the patent database, but the data is not structured. So there is no way we could use that. So this was a huge roadblock for us. And this is when we came up with something really interesting called as TRIZ. So for the last 6 to 7 years, I've been doing a lot of research on TRIZ, and I'll take you through a very short, lovely historical story. It was 1946, and there is this Russian man, exactly like Einstein. He was working in a patent office in the Soviet Union, Russia. And his job was just to stamp every single innovation or a patent that comes to his desk. While doing so, he got so bored with his job, he asked this question: how people innovate? Are innovators really born? Or is there any particular process that gets into the process of innovation? Before he could start, he wanted to identify or define a problem. Innovation is nothing but a disruptive way of solving a problem, right? And this is where the core or a big breakthrough in our journey came from. Defining a problem. The way this guy defined a problem was, problem is nothing but a contradiction. What I mean by a contradiction is, if you're trying to improve a particular parameter, there is another parameter which comes along with it. Let me give a very simple example. We have a policeman, and let's say he has a bulletproof vest, right, to protect himself. Now, The goal is to make the bulletproof waist as strong as possible so that it can take the momentum of the bullet, which means that it's going to be heavy. But at the same time, if the bulletproof waist is heavy, the policeman can't run. He's going to be tired. So now there is a contradiction. I want the bulletproof waist to be heavy and light at the same time, right? So this is exactly where this is called the contradiction, and this is where innovation comes into play. If I'm able to resolve these kinds of contradictions, I have a patent, or I have a white paper, or I have a commercial idea or a proof of concept to sell. Now, once this contradiction was defined, he went through 100,000 patents from 1946 to 1980 and came up with a big breakthrough. He said that looking at all these 100,000 patents, there are just 40 basic principles that gets into 95% of the innovations. And if people know these basic 40 principles, anyone could be an innovator. Fantastic, isn't it? And these principles are very, very straightforward. It is like, for example, there is a principle called as nesting, which is nothing but putting one inside the other, like a telescope. Or it could be segmentation, which is like breaking a particular component into multiple parts. So we just have these 40 basic principles, and that's gonna answer close to 100,000 innovations. Now, this is exactly what we wanted. Now we have a complete training data set for 100,000 patents, which means we captured the intelligence of 100,000 Soviet scientists, which was readily available for us on Google. And it was a structured data. Now, this is how a contradiction matrix looks like. So the way he structured these entire 100,000 innovations in a particular format, and he called it a contradiction matrix. So what he said was, okay, what is the parameter that you would like to improve? Let me say I want to improve the automatability of a process. Great. What is it that's stopping you from developing it? I would say the input data format is not right. So for these two combinations, there could be 2 or 3 principles in the contradiction matrix that you can use and resolve it. So, which means I have a system over there that is intelligent enough than a human being carrying the intelligence of 100,000 scientists to resolve contradictions for me. So now it can go even a step further. I'll be covering that soon. And so there is a very common question that people ask me as to, if we have TRIZ, this is called the theory of inventive problem solving, which is a Russian acronym. If this process is so efficient, why is it not as popular as a Lean or Six Sigma? The reason being, until the Soviet Union broke down, this was with the Soviet military. And in 1992, this methodology came out and it went to US. Now all the Apple and the Samsung phones that is being used uses the TRIZ methodology to design their processes. So it's a fantastic methodology. And so this is one side of the story on what is TRIZ all about at a very, very high level. Now, coming back to the problem that we were trying to solve. What we did was, we took this contradiction matrix and created an app. What this app does is, it talks to the user. It's a simple chatbot, asks a series of questions to the user, and tries to understand the parameter the user is trying to resolve. It could be the speed, or it could be reducing the cycle time of a process, it could be reducing inventory, etc. And it will also try to understand what is that particular parameter the user that is stopping the user from improving. Once these two parameters are identified, then we come to the principles. So the chatbot will start asking the user, hey, what will happen if you break the product into two parts? What will happen if you break it and try to put one inside the other? A very methodology-driven approach towards a resolution, and by the end of the process, the user has a solution. Let me give you a very simple example of using these chatbots and some of the use cases. For one of a big pharma company in UK, they had to increase their sale. And the problem the customer came up with was very, very vague. That is, there are too many competitors in the market, and their particular product, the one that they were targeting, was cough syrups. And as we all know, cough syrup is a very, very, very generic product in the market. And as a user, it doesn't need prescription. You just go pick it up. And the best thing is the climate of UK makes sure that everyone needs cough syrup. It's always gloomy and etc. Now, how do they go ahead and improve it? So one of the marketing VPs was the initial guinea pig for our chatbot. So when he started chatting with it, it took him through the entire process, etc. But let me tell you, the long story short, it identified that this particular product, when the user gets into a pharmacy, there are different types of coughs which people have. It could be an itchy cough, it could be, different types. And the user doesn't know, the customer doesn't know when he looks at the cough syrup shelf in a pharmacy, he doesn't know which one he has to pick. And there is a principle called as a color change, which means change the way a user looks at a particular brand or something. And this AI suggested him that, why don't you mention the different types of coughs people have, and this cough syrup can resolve all those issues or problems. Bang. And so far, as of today, this solution was implemented in the mid of 2014, and the sales increase is up to 2.3 billion so far, right? And it did not use any innovator, and it was an AI that was used here. And that was the first guinea pig, and we found few more successes, and we went a step ahead. As this product was innovated in collaboration with another innovator in Greece, we called it Athena, which is the equivalence of the Greek god for intelligence. And this AI now is going to author a book on innovation. It will be the world's first AI to author a book on innovation, which is going to tell how intelligent is the human being who's chatting with me. And this is going to be the book all about. And it all works on this very simple principle called as TRIZ. Let me quickly take you through how a contradiction metric looks like. And any one of you here, if you can give a problem, I'll quickly take you through it. And let's try to solve a small problem now. Now, what parameter do I want to improve? For example, let's say I want to improve the, oops, it doesn't, yep. Accuracy as well, like how good am I? How can I want to increase the accuracy of processing the loan applications that is being filled. And what is stopping me is the complexity of the device. It could be the complexity of my organization. There are multiple handoffs. So what is complexity? Complexity is directly proportional to the number of handoffs that I have. So accuracy and complexity forms a contradiction now. And these are the simple three principles that can be used. So what it says is, the first one, copying. Copying is, don't work on the original copies, instead make multiple copies of a particular data or a system and start using it. Second one, what it says is taking out or separation, or in lean, what we call as the remove the non-value adds. Take out everything that is not adding value. For example, if in the bottom of the loan application, if you have a particular section for like terms and conditions, etc., which is not required for your process, remove it off. It's not required. That way you increase the accuracy and your focus moves towards the particular fields that's required. And next one is the mechanical vibration, which means whatever is the mechanical system involved in your process. It could be if a human is typing, why don't you use an RPA to replace that particular mechanical system and increase the vibration, which is nothing but the speed. So, which means that for a particular problem of mine, I have found a contradiction, I have 3 or more solutions for it, and it could be a potential white paper. As simple as that. So in overall, there are 39 parameters in total and 40 principles. So the 39 parameters are automatability. And automatability is the key, because most of the industries, and this is what the research says as well, like they look at RPA solutions as a productivity tool. But it can go beyond for speed, reducing the operational cost, increasing the sales, reducing the inventory, increasing the accuracy of manufacturing, increasing the precision of a particular process. It can go beyond. So just by choosing automatability as my improving parameter, and for every single parameter that is stopping it, the precision, the accuracy, the complexity of the system, etc., I get multiple principles, which means I can use one simple tool to solve a series of problems and get the complete juice out of the automation rather than just looking at it as a productivity tool. So this is the beauty of TRIZ, and all that is required is, this was created in the 1980s, so all you have to do is just get into Google and say TRIZ contradiction matrix. You get all these principles and it can be used. Now, going back to my slides. Sorry. In 2014 mid, what I did was, using this chatbot tool, Athena, which was the name that we got it later, I traveled from Thailand to Portugal on a bicycle, covering 21 countries, to identify how many innovations can we come up with in a span of 2 years. It was astounding. We came up with close to 186 innovations in 500 days, all done by an AI. And this cuts across innovations in universities, innovations in corporations, municipality of Iran. Lot of vineyards had millions of dollars of impact using this particular chatbot in Georgia and Armenia, which is one of the top wine producing nations in the world. It was used across industries. Fantastic, and that gave me an opportunity to author a book as well for how can we use TRIZ for business innovations. This is how a TRIZ contradiction matrix would look like. This is the original contradiction matrix that was designed by Generic Alstiller, and you have the improving parameters and what is worsening. So all that we need to do is, if we have automations here, automatability, just run it through completely. You have each and every parameter. Like for example, is risk a big factor for me to automate something? So for risk and automation, you will have a set of principles that can resolve the problem and innovate. So TRIZ plays a really, really key role. And the most beautiful part of TRIZ is these principles can automatically generate a data set, a training data set for AI. Now, once we started working on these, the last part is how do we sell these innovations? These are extremely disruptive, unlike process standardization innovations. So this was the biggest challenge that we came across. And one technique that we found works really, really well to sell any innovation. to a CEO of a company or a vice president of innovation, etc., is using 1/10 of an elevator speech. So let me say pre and post. What we used to do was, the moment we go to the boardroom, meet a CEO, and explain them about Athena, which he is not interested about, then about the business problems that he can solve, okay, and the approach that we would take, he's already lost the interest. So something interesting came up, which was again suggested by Athena. This is again an innovation by Athena, is, how many of you know this movie? Speed, right? Great. In Hollywood, they use the upcoming or the aspiring directors use this technique. For example, if someone wants to, or I want to go and tell a story to Steven Spielberg, I can't go to his home. He's a big guy, right? So what I do is, we go to the favorite restaurants where Spielberg would come, and the time he gets down from the car and gets into the restaurant, I have those 10 seconds or 5 seconds to just rush through and tell my idea to him. That's exactly how an innovative idea has to be communicated. The best way for me to tell Spielberg that I have a beautiful script for a movie called Speed is to tell him, you know what, I'm going to shoot Die Hard in a bus, right? Something that's already solved, and I'm going to be doing it in a bus, which means that immediately it rings. It strikes a bell, which means a known innovation in a new environment is what the new innovation that we are trying to sell here. Simple. So this one really works in packaging and communicating the innovations to the potential customers. And the second most important thing that we also experienced during the process of selling the innovations that we came across was the stakeholders whom we meet, the attitude and the attitude of the person, developing the AI solution or the RPA, and the one who is implementing or consuming it. The attitude shift has to be completely different. For example, let me give a very simple story. This man, anyone know about him? Good. Even I didn't before a couple of months. So this man was a really crazy innovator. What he did was he experimented, and he was the first man who wanted to fly. He was a tailor, and he designed this dress for himself, went on to the Eiffel Tower and jumped. And apparently it was a failure. And the place where he jumped, the depth of the fall was 3 meters. There was a 3-meter hole when he fell down. So which means this is the kind of passion that we talk about when you're trying to innovate something, really into it, trying to do something, go beyond being very disruptive. And this man is the pilot who just flew from Hyderabad to Bangalore, just arrived. Would you think I'll board the flight if this guy has the attitude of this guy? No way, I'm not going to get into the flight. Impossible. So this is the exact same thing. When what we learned was, be it McKinsey or any other consulting firms, when they take us to a particular boardroom, it really matters. If I am talking to an innovator or the innovation team, I would be showcasing this attitude or a personality of mine. Whereas if I'm talking to a process or an operations manager or a director of operations where risk is the key, I would be talking this language. So this is what is the key for selling an innovation that I've learned so far. And this is all I had. So TRIZ is a wonder. In short, TRIZ is a fantastic tool to identify innovation opportunities for RPA, AI, etc. And if it can be packaged and sold well, it's going to be a complete disruptive innovation beyond just looking at point automations. I'll take up the questions during the roundtable. Thank you.